Hello, good day everyone. So this is a short lecture on how to interpret PCR results or how to read PCR results. So just a disclaimer, I am basing this lecture on my experience in working at a molecular laboratory for SARS-CoV-2 testing. So there we performed RT-PCR. So my short lecture for today is based on that experience. Okay, so but it's pretty much similar. So it's pretty much similar to other PCR tests. Okay, so the PCR tests here are designed to look for a virus genetic material. So, dili ra siya restricted sa virus, guys. Pwede pod bacteria. But for me, for my discussion, karon, I'll base it on a virus. Okay? So PCR tests tell you if the virus is detected, so positive or not, which is negative. Okay, so each PCR test has cutoff points. Okay, and the number of cycles it runs, which tells the machine to stop running the test. So it is important to note that different brands of those who make the PCR tests may have different cutoff values based on how sensitive the test is and how it is designed. So one of the things that you have to remember, or one of the terms that you have to remember in PCR is cycle threshold. So cycle threshold is the number of cycles required for the fluorescent signal to cross the threshold line. Okay, so meaning it's the number of cycles required for the fluorescent signal to exceed background level or background noise. It is inversely proportional to the amount of target nucleic acid in the sample. So different analytes have different cycle thresholds. So for SARS-CoV-2, usually the cycle threshold or the CT value is 40, 40. So for every PCR test, there is always an amplification plot. Okay, so this is an amplification plot. In the y-axis is the fluorescence intensity. Okay, so this is our fluorescence intensity here, y-axis. On the x-axis is the number of PCR cycles. So there's 5, 10, 15, 20, 25 until 50 for this plot. Okay, so the plot of cycle numbers versus fluorescence signal, which correlates with the initial amount of target nucleic acid during the exponential phase of PCR. That is what the amplification plot presents. So, okay, so again, the amplification plot presents the fluorescence level of the samples being analyzed. So, ang fluorescence level na gipresent sa chart is correlated with the number of cycles needed for the sample to reach that corresponding amount of fluorescence. So the next part of this amplification plot is the baseline. Okay, so the baseline is the initial cycles of PCR during which there is little change in fluorescence signal. So makabantay mo ana mga lines nga daghan kaayo nga magdungan. Mao na siya ang baseline or kanang same ra sila og level gani. Mao na siya ang baseline. Okay, so one of the things that you have to remember here in the amplification plot is there are different tests nga nag-use og different color of fluorescent dyes. So kung unsay color sa line sa graph, that is the color of the fluorescent dye being used. So for our plot karon, the fluorescent dye being used here is, unsa man nga color? It's color red. Okay, so ako na ni siyang giingon ganina but I will reiterate it now. So the threshold of the real-time PCR reaction or the yes, of the PCR test is the level of signal that reflects a statistically significant increase over the calculated baseline signal. Okay, so this is our cutoff, meaning any increase of fluorescence over the threshold is significant. Okay, so fluorescence below that is not important. It is set to differentiate relevant amplification from the background. Okay, so the point where the threshold line and the increase of amplification of the sample crosses is the CT value of our sample. Alright, so as you can see on the screen, this is the cycle number at which the fluorescent signal of the reaction crosses the threshold. Kaning akong gi-circlean there og red. So, the CT value of our sample is pila man. Correlate na to ang fluorescence intensity sa y-axis sa iyahang number of cycles sa x. So, pila man na? That would be approximately mga 32 or mga 31.5, no? Or 32, kay 32.5 man ang tunga-tunga sa 30 to 35. So the CT value of this sample with a red fluorescence is 32. If ever ang cutoff sa CT value for this test is 40, what is the interpretation for this? Is it a positive or is it a negative? So again, it is a positive. Kay 40 below gani, meaning ang amount of analyte in the sample is daghan. So it takes a lesser number of cycles to amplify that specific target. So if it is below the cutoff of the cycle cutoff, then it is positive. So the amplification plot here has three phases: the exponential phase, the linear phase, and the plateau phase. Okay, so let's just define the three phases. The exponential phase is the exact doubling of product, in the exponential phase rather, exact doubling of product is accumulating at every cycle. So assuming that there's 100% reaction efficiency. So here the reaction is very specific and precise. The linear phase has high variability. In this phase, the reaction components are being consumed. The reaction is slowing and the products are starting to degrade. Finally, in the plateau phase, the reaction has stopped. So no more products are being made, and if left long enough, the PCR products will begin to degrade. So this is another example of an amplification plot. Okay, so each PCR test has target genes na ilang gidetect. And the reagents in a specific test allows those target genes, if present in the sample, to get amplified. So the numbers on the x-axis is the cycle number. So as more cycles are run, more copies of the DNA are made. So it's doubling every time it is copied and making it easier to find. Okay, so the lines at the bottom show the DNA samples getting amplified. So take note that that is not the fluorescence that we want. Okay, so that is just the background fluorescence or the background noise. So background fluorescence might be due to the instrument setup and imaging parameters. So for example, light from the excitation source, camera noise, and ambient light. So, naapoy uban background fluorescence na because of the autofluorescence of the samples, the vessels, and the imaging media, or fluorescence resulting from fluorophores not bound to specific targets. So the green line there is the threshold value, and again, every PCR test has a specific threshold value. So as can be seen on the screen, there is a red line there. So that is a red fluorescence that crossed the threshold value at cycle 21. Okay, so this means that 21 cycles are required for this amplification to cross the threshold value. So let's say that the CT value cut off of our test is 40, meaning this means that this result is strongly positive. Meanwhile, at 39 cycles, there is another line that crossed. So there's a green fluorescence that crossed there. This is still positive. Kay 40 man ato ang cutoff, but this is weakly positive na. Okay? So, based on this discussion, we have learned that the cycle threshold value is inversely proportional, okay, to the amount of target nucleic acid in the sample. Meaning, the lower the CT level, the greater the amount of target nucleic acid in the sample. Okay, so, so the cycle threshold value is the actual number of cycles it takes for the PCR test to detect the virus. So it indicates that it indicates an estimate of how much virus was likely in the sample to start with. Okay, it's not the actual amount. So if the virus is found in a low number of cycles, so let's say CT value of under 30, it means that the virus was easier to find in the sample, and that the sample started out with a large number of the virus. Meaning, ang sample ni mo na ana siya daghang amount, daghan nga viral load kay taas na daan. Okay? So, think about it. Ato siya i-compare of something simple. Think about it using the zoom button on your computer. Okay. So, let's say ang default niya is 100%. If imo siyang i-zoom gamay, at least, let's say, 110%, niya dako na, maklaro na jud siya maayo, it means that the item on your screen was big to start with na daan. Okay? Just that's equivalent to having a low cycle threshold value. Yeah, for example, you have to zoom it a lot more. Let's say you have to zoom it at 180%. Now it means that the item on the screen was small to start with. So, ingana rin na siya o comparison. So, therefore, the more number of analytes present in the sample, the less number of cycles is required for amplification. Okay? So, on the other hand, the less number of particles present, the more number of cycles are required to cross that particular threshold. Okay, so this ends my short lecture for reading PCR results and interpreting PCR results. Okay, so I hope that you learned something from this lecture, and thank you very much.